Yes, sir. Very good afternoon. Am I audible to you? Just please write yes on a chat box if I am audible to you. Hello. Yeah. Yes. Thank you, Ankur. Let us uh, begin with the next topic. Yes, we are doing the supervised learning, and previously we have covered the uh, KNN method and decision tree. And as we know that, what are the advantages and disadvantages uh, of KNN method as well as for the decision tree. And there are after that we have also covered that how to convert the tree into the rules. And then there is a and then uh, there is a random forest. And after random forest, we will do the sport vector machine. So the sport vector machine is the last one from the different categories of the supervised learning. And up to 20th lecture, there is a the ST1 will be prepared. Okay, so you can expect up to sport vector machine your ST1 syllabus. And currently, we are in today's lecture we will do the random forest, and in next 2 days we will do the uh, this one sport vector machine, and on Thursday we will do the a short discussion on the various topics that whatever we have covered and what type of questions you can expect in the ST1. So let us begin. Okay, before understanding the concept of the random forest, and you must be clear about the decision tree. So if you have uh, still don't know the how decision tree works, then you have to go through it. Then after that, you can easily understand the random forest. So in order to just I will give the brief introduction uh, to the decision tree before covering the random forest. And in a previous lecture, we have covered a decision tree. And decision tree here, you can see that there is a one second. Just I will cover decision tree very briefly. So in a decision tree, we have covered the various parameters that is linked with the decision tree. There is the first one is there is a decision nodes are there. These are the decision nodes where we can put the rules, and these are your leaf nodes. And these two important parameters, and here you can see that this one is a these three are leaf nodes, and these two are your decision nodes. So you must be aware of these two important terms which are related to the tree. And why it is called as a decision tree? Because your outputs become like a tree format. And here we can see that there is a tree structure is there. And how this tree structure will be prepared, that is depend upon the what the divisions, whatever the divisions we have made in this space. So this is referred to as a space. And if you are, I'm just little bit cover this example. And this we have done the if there is an space which is divided into the two parts, and here you can see that there is a LOC. This one is a LOC, and this one is a time is there. Yes, uh, time is there. So in a LOC, if LOC is less than one, if this one, if LOC is less than 15, here we can say it as a this one is a 15. Then we can say it as a this one is a region 1. Otherwise, we can say it as a region 2. So this is a simple formation or a division of a space. And if you want to further subdivide the image, subdivide the space, then you can do it very easily. And once you have this one is your region 1 is covered, and this one is your region 2. And if you further want to divide this region 2, then you have to apply the another parameter on the x-axis. So here you can see that there is a time is there. If the time is less than 3, this one is a 3. If the time is less than 3, then you can say it as a region 2-1. This one region 2-1. Otherwise, you can say it as a region 2-2. So this is a further you can also divide into the any number of points. So this is a basic concept of the decision tree, and here we can easily see that there is a problem of overfitting. There is a problem of overfitting in the decision tree, and which we are going to remove with the help of the random tree. So this example that we have done in a previous lecture, and okay, yeah, there is a overfitting problem is there that we are going to remove in random forest. So let us do the random forest. Yeah, let us start with this slide. Okay, as we know that the random forest is a part of the supervised classifier or of supervised learning, and which is a further part of machine learning, and the machine learning is a part of artificial intelligence. Now, let us start with the random forest, and here you can just go through this definition. It is the random forest is nothing but is an assembled classifier that consists of the many decision trees. So here you can see that this is just a collection of the number of decision trees as we have covered in the previous lecture, and the outputs, the class, that is the mode of class outputs by individual trees. So here you can see that this one is a tree 1. This is you can say it as a this one is a tree 1, or you can say it as a decision tree, and this one is a decision tree 2, and this one is a decision tree 3. So and the collection of all these three is actually referred to as a random forest. Hopefully you are able to get my point. So the term, the random forest term, came from the random decision forest. And yes, there are some different names of the random forest. You can also say it as a random decision forest, and you can also say it as a random decision tree. So there are multiple names of this random forest, but actual meaning is a collection of the number of or multiple trees. And this method combines the beginning that I will cover in a little bit later, and in which there is a random selection of the features, and how we can see it that we will do in upcoming slides. And first, we have to understand that what are the actual applications of the uh, random forest and why we have designed this random forest. And now, basically, we can use a random forest classifier in a remote sensing images. And this one is a Earth image. You can say it as a, and it is used in the there is a enhanced thematic mapper devices to acquire the images of land surface. So, and yes, the what are the advantages? Yes, accuracy is higher and the training time is less as compared to the as compared to the other classifier. But here we can't say it as a that is a better than the decision tree because it is actually a there is a collection of the multiple decision trees. So this is the first application. You can just remember that. And now there is a next application is there. There is a object detection and object object detection. Okay, first you have to maybe you all have clear about the what are the remote sensing images. Remote sensing is whatever the images which is acquired by the Google Earth. You can say it as a remote sensing images, and but there is a collection of the multiple satellite images. There is the Google Earth is actually a huge database uh, of Earth images which are acquired by the different satellite sensors. So that kind of image is referred to as a remote sensing image, and on that remote sensing image, we will apply the classifier. And what kind of a classifier? That is here we are talking about the random forest, and by which we will get the maximum accuracy and with less training time. So we can also utilize the random forest in the object detections. And what kind of object detections? You can say it as a there is a different cars are there. This one is a taxi is there. There are buses there. There is a personal vehicle is there, and we can also use it in the detection of the fruits, vegetables, etc. And here you can see that there is a multi-class object detection is done using the random forest. Yes, multi-class you can say it as a this one is a one type of a car, this one is a second type of a car, and this one is a third type of a car. So we can use it for the multi-class object detection and provide the better detection in a complicated environment. Yes, here you can see that in this figure. And yes, here you can see that in second figure there is a multiple vehicles are there, and but the image of the third vehicle is not fully visualized. And here you can see that there is another class in front of the third class. There is a second class or a first class in the front of third class, and the third class is not properly visible, or a third object is not properly visible. But yes, it can detect very easily. So that is a main advantage of the or a important feature of the random forest. And yes, there is a Kinect. Kinect is basically a yes. This is a gaming console. That is a, how it works. That is a, it tracks the body movements, and how it will do that we will discuss in this example. And here you can see that there is a user is there, and it a user performs a step, and there is a yes, there is a device which converts the movements into the you can say it as a into yes, you can say it as a digital format, and marks the user based on their accuracy. And this game maybe you have played, and may not be you have played, but you are aware of that what kind of a game is there and how it does. Basically, there is a training sets to identify the body parts. Yes, these are the training sets which is given to the random forest classifier so that it can identify that what are the hands, and where is your shoes, and where is your face. So these are the some important features. Then you have to give to the random forest classifier so that he can learn various steps. And once it will get the information, then once it identifies the various parts of the body, then it will just replace your body with the another one. So this is the kind of a game is that. And Yes, this is a basic this is a basic slide that we have put it here. Uh, yes, this one is a supervised learning. Then a supervised learning is a kind of, yes. There is a one important rule is there, not important. So there is a one more important type is there. There is a regression that we have already told you in first or second lecture. The supervised classifier can be divided into the two parts. That is, the first one is a classification and another one is a regression. So regression is there, but we will not discuss in this chapter what is the regression. But yes, first we will do the classifications, and classification we have covered this part, and this will not we will cover this will not cover in this subject, and this will definitely we have covered this part, and we are currently doing this part. So why there is a requirement of the random forest? Okay, there are first of all there is a that we have discussed about that there is a overfitting problem in a decision tree, but yes, in a random forest we can remove overfitting problems, and how we can do it that we will discuss in upcoming examples. But yes, you have to remember that there is a no overfitting problem in the random forest, and the use of multiple trees, or you can say it as a use of the multiple decision trees reduce the risk of overfitting. And in the previous, we have seen that a single decision tree have a lot of overfitting problems. And but yes, if you use the huge collection of the decision tree, then you can overcome this problem. How we can do this? That we will discuss. Uh, and the training time, yes, we have already covered this part. The training time is less. Yes, the higher accuracy. Yes, due to the large number of decision tree, the accuracy will definitely be high. And yes, it is used to identify the uh, missing data. And random forest can maintain the accuracy when a large proportion of the data is missing. How it will do that? Let's see. And here we will do the uh, this is, let us start with the example, and each example start with the decision tree. And here I will not explain you the what is a decision tree is, and but you have to just go through this point. This one is a decision tree one, and according to the decision tree according to the first decision tree, you will get the output apple, and according to the decision tree two, you will get the output 2, and according to the decision tree you will get output 3. So there are three outputs are there. So basically you are putting the entire, this is a training data set, that is whatever you have done, and this one is actually a random forest. So you have to identify that what kind of information available in this random forest. And according to me, according to this, there are two apples are there, and according to this, there is a one and two. Two apples are there, and the one here you can see that this one is a one mango is there. So on the basis of the majority, we will come into the final decision, which is as a apple. So there is a maximum. Definitely, it will assign the class to a pixel or a. One second, hold for a second. Yes, in this, there is a, on the basis of the majority, it will come to the final decision. So this is actually a flow of a random forest. How it will work, and let us begin with uh, a brief example that will that will expand by one. And yes, here you can see that in a ball there are multiple fruits are there, or you can say that there are only two fruits are there. The first one is this one is orange and apple is there, and we have to identify. We can also do it with the help of yes. There is a third fruit is there. We can say it as a cherry, and there are three fruits are there. So if we will categorize these fruits with respect to color, then you will not come to the decision. In order to that, you have to identify that with respect to the diameter. So once if the diameter is greater than 3, and yes, the diameter of the cherry is less as compared to the orange and apples. So according to this is a false. The diameter of the cherry is less as compared to the uh, orange and the apples. Now you can apply the color combination over that. Once you apply the color combination, then you will get the actual is color orange. Yes. If it is a yes, then you can say it as a orange. Otherwise, you can say it as a apple. So this is a very brief example, and hopefully you have uh, already have a knowledge what we have done in the previous lecture and during the decision tree lecture. That one is a benefit. There are some there are some important definitions or important examples we have already covered in decision tree. So this is also a kind of a decision tree, but yes, the huge mixture. This one is a very basic example, but you can also consider it as a there are multiple fruits are there, not only two or three. Or you can also take it the example of 5 to 6 fruits are there, and you can categorize it into the uh, final value. So yes, there are some important terms which are related to the random forest, and the first one is a entropy. Entropy is a measure of the randomness or unpredictability in the data set. So and the second is information. Second is the information gain, and the third one is a leaf node is there, and decision node is there. Last one is a root node. So hopefully you all are cleared with the leaf node and the decision node, but we will also discuss in this upcoming slides. But I have covered these 2 points in a previous lecture and during the in a decision tree lecture. And let us we will discuss one by one. And first we will start with the entropy. Yes, the entropy is a measure of randomness, as we have already covered. Okay. Yes, here you can see that there is an example, and and it is further separated into the two parts. And this one is a set one, and this one is a set two. Now you have to tell me. Uh, okay, I will give you this example. This one is a one, and this one is a two. So I will give you the two inputs, and you just tell me where is the randomness is more, in a first point or in a second point. And hopefully you will just mark this. This one is a high. There is a high randomness in a first example, and there is a low randomness um, in a second example. And so, on the basis of the randomness, either high or low, we can say it as a high entropy or a lower entropy. And this one is this is where the randomness is higher, we can say it as there is a high entropy, and where the randomness is low, then we can say it as a lower entropy. So these are the basic terms then that you have to be able to learn. And how we have done. Okay, let us go to the next important point, which is referred to as the information gain. Now, what is the information gain? Information is actually a what the information, we can write it as a, there is a information gain is there, whatever we have learned by whatever the information we have learned by moving from the E1 to E2. So here this one is a E1 and this one is also E1 is there and E2 is there. This is a flow chart and there is a high randomness in the case of E1 and we have split it into the two parts by making the this one. And how you can hopefully I am expecting that you can easily apply this rule uh, uh, here. This one is a this one is a space and here you can apply the rule and which further divides the this entire space into the two parts. There is a first space is there, there is a two spaces there, and these two spaces, that is a splitted spaces, and we can say it as a E2, and this one is a non-splitted E1, and the transformation from the E1 to E2, or we can say it as a transformation from the high entropy to the lower entropy, whatever we have got, it's a kind of a information gain. So we can say it as a, it is a measure of a decrease in entropy after the dataset is split. So this is the second term. You have to remember it in a decision forest. And these two here, once I will go to the back slide, and yes, the entropy is a term which is added to the random forest, and there is an information gain which is added to the random forest. Now we will do the leaf node and the decision node, and yeah, here you can see that there is a yes, these two are the that is a decision. There is a split it into the two parts, and this is further split on the basis of color. You can do it by just adding the color. Which one is a red and which one is a yellow. And here you can also do it this. And at the end you will get the maximum majority of the apples. Then you can say it as a apples. And if your majority is there is a mangoes, then you can say it as a there is a mangoes. So, what is the purpose? That is the end results. These are your end results, and which are actually referred to as a leaf nodes. That we have already covered this part, and these are your rules where you can apply the rules. And this one is basically the initial database, but actually you will apply the rules over on this part and over these two parts. So, whatever the rectangular box is, uh, okay, that will conflict with the our previous example. But yes, whatever whoever boxes who take the decision, that are referred to as a decision nodes, and your end result will actually refer to as a leaf nodes. So hopefully you all are able to understand this concept. What are the what is entropy, what is information gain, and what are the decision nodes and the leaf nodes. And there is a last one important term which is related to the random forest, that is called as a root node. So uh, here we can say it as a, this one is a decision nodes. This one is a decision node, and this one is a leaf node. And your main input data set where actually tree begins, that is referred to as a root node. So your this one is a one kind of a decision tree. This one is another kind of a decision tree, and your actual entire concept is referred to as a your entire concept is actually referred to as a random forest, and this main input data set is generally referred to as a root node, or we can say it as a topmost decision node is also known as the root node. So hopefully you all are able to get my point. And yes, there are different trees are there. So the basic functionality of the here you can understand the difference between trees and random forest. And here you can see that this is an example of a decision tree one. Yeah, this is a decision tree, and we have categorizing the this one. And here you can see that we have already covered this example in which the cherry and in which the fruits are divided on the basis of diameter. And further, we have divided into the two parts, and we have divided on the basis of the color. So here we will get basically we have applied this tree to identify the oranges, and your second tree is basically designed to identify the cherries, and your again your third they have designed actually this one is not this one for apple, and hopefully your third decision tree must be for the uh, apple. You can design it for the apple. So your first tree is must be designed for the one fruit, and your second tree can be designed for the another fruit, and your third tree can be designed for the another. So here we have first select the orange, and here you can easily check it out. Yes, yeah, cherry is there. Okay, and here you can see that they have applied the first rule diameter, and here they have applied the color. But in another case, first they have applied the color, then you can apply the diameter. So here they have just implemented the shape or a circle, but yes, according to you can also apply this concept here. So that is a interchange. You have done the by interchanging the rules, you will get into the another result. So as we have already covered these points, your random forest is a sorry. You can convert your classifier decision tree classifier into the set of rules. And what kind of rules are there? These are the actual rules. Whatever you have to make it. And here there is a third tree here for the third fruit. Now the collection of all these. Now the collection of all these trees, we can say it as a this one is a random forest. And hopefully you are able to understand this concept. What is the decision tree and what is a random forest, and how we can differentiate the random forest and the decision tree. So in order to understand the random forest, you must be aware of the decision tree. So that is a entire concept, and according to me, there is no any there is separate explanation is required in terms of working in a random forest once you have cleared with the decision tree concept. So if there is any question, we then I can handle it. Then please you can ask the question if there is any question in the random forest or in decision tree. Then we have a time. Okay, you can ask the question. Uh, okay, you most of the students have not. Okay, who is there? Yes. Okay. Anyone can tell me the answer. Um are you following any book in order to learn the or in order to just read the concept of a machine learning? Are you referred any book till now? this is my question to all. If no, then okay. Currently, you are not following any book. Okay, fine. Today, okay. I will send you the books, and now this one is your the basic book that you have to follow. And here we have also okay. Here we have also written there, and it is easily available from the Google. You just have to search it Introduction to Machine Learning, and then you will get the this book first. And this one you can also download ebook for this one. But yes, according to me, this one is sufficient. And and yes, the first chapter I have covered with the help of this book. And here you can see that there is a the first example, uh, whatever I have followed. Yes, yes. This is a classification. Whatever I have covered in a first lecture. That is okay. That is the basic details are there. So in a second chapter, you have to follow the second chapter. Yes, learning a class and learning multiple classes. That I have covered from this book. And you can, if there is any query or any detail is required, you can just please go through this book. So I have this, I have took those examples from this book, and that is a learning multiple classes. And again, this is a these are the graphs. You all are familiar with it now, and you can follow this book. And but you have to be you just have to go through your specific points, whatever we have covered. And according to me, KNN, it is not, it's not actually much cleared with this book, and there is a no deep details are there. But yes, you can go through this book, or you can also download some other books which are related to the machine learning. And you have to do this kind of a classifiers. There is a decision tree, and KNN classifier is there, and the random forest, and the SVM. Okay, you can do it with the help of the uh, with the help of any other book, or you can also search it for a specific topic. And according to me, for these type of topics, you don't need to go through the any specific book uh, or any chapter. But yes, you can directly search it through the internet. What is a sport vector machine, and what are their examples? And similar for the random forest, there are huge examples are there. There is a programming is already available over the internet. You can just check it out and go through it. And similar for this unsupervised classifier, there is a k-mean clustering, hierarchical clustering, regression, and yes, but the basic concept for understanding this one, for understanding the basic concepts, that is introduction to the there is a to clustering, there is a learning class form example, learning multiple classes, and then you have to go through the book. So these are the some important points, and this one is your main textbook that you have to be followed for this course. And yes, here you can just check it out. There are inner contents. Most of the syllabus is already available in this book, but I recommend you to just there is a decision tree is there, but yes, you have to just search it out over the internet. You will get the better examples and more examples. And they have given in this book, they have given only the one or two examples are there, but yes, you have to go through the multiple examples. And yes, in this book they have not uh, covered the random forest. For that you can just okay. Uh, I'm not sure about that. Is there any random forest is there or not? But yes, that is very obvious. The random forest is just an extended version of the decision tree. But yes, for the random forest, you can again go through the specific topic, or you can search it out through over the internet. So, if you will not get this book from the internet, then you can please let me know in another lecture. I will just send you via WhatsApp. Okay. And is there any question related to the random forest, till the random forest? Then you can please ask me. Uh, and once again, the links are not yet active, so you no need to just mark your attendance now. Yes, you can just okay. One thing I also let you know. Now, this PPT, you can just go through the internet and you can just search it out the random forest. And there is a YouTube video is available which is uploaded by the this Simply Learn. And this entire concept is taken from that example, which is not particularly available in a book. But yes, I have taken those slides from there, and these are very informative, and you can just go through it, and you will get the better knowledge as a part of your programming. So according to me, if you want to do some practical things, then you can definitely go through this video, that is which is uploaded by the Simply Learn. And okay, this Saturday you have exams, ST1, and next Saturday we will do some experiment part, so that you are able to understand where we can and how we can implement the different classifiers. And yes, if there is any question, then you can please write it on our chat box, and with otherwise within a 1 minute, I will activate this link so that you can mark your attendance. Yes, please, you can ask the question.